Welcome to the course on machine learning models and Power BI, where we're going to develop AutoML and other ML solutions with Power BI. The course is going to be covering quite a few different techniques and aspects, but I promise you at the end you'll be pretty familiar with all of the steps that are needed to build a machine learning model and use AutoML and Power BI. So here's the agenda. We're going to do a little bit of data wrangling where you can review some Python. So if you're new to Python, this will be very helpful. We're going to do an unsupervised machine learning model. So that's going to follow the same process of looking at an intro, AutoML solutions, developing a model from scratch, and dashboard development. Then we'll go into supervised machine learning models where we're going to dive into regression and classification. So you're going to have two sections there. And the same, we'll go through an intro, AutoML solutions, develop a model from scratch, and dashboard development. So when we're talking about AutoML, this is what we're really talking about. We're talking about using Pycaret. Now, what is Pycaret? So Pycaret is a API solution that has various machine learning models. These models are based on the sklearn library. It's really suitable for beginners. It's easy to use because it has all of the steps such as data processing, model selection, and tuning. Generate some nice reports and visualizations, so we're going to dive into that. Then we're going to also build manual models so you can understand what's going on under the hood. And we're going to be using that sklearn library, which is widely used. It offers also tuning, visualizations. It requires a little bit more Python, but I thought this would be a good addition to everything. There's no automation really in it, and it's really customizable. So we're going to dive into some clustering with Pycaret, and just to give you kind of the normal run up to using a Pycaret pipeline. Here we go, because Pycaret is a low-code solution that allows us to kind of dive into some quick and easy ML building. So we're going to do a Pycaret intro, and that's just importing the files. And connecting to the API. Then we get our data set. We do some EDA. We set up the Pycaret environment. We compare, evaluate, and create models. And then we plot our models. And then we should also put another heading here called saving our model. Shift and enter that. So let's get started with importing Pycaret. Now, if you don't have Pycaret on your machine, you need to install it. Now you can do this through your prompt if you have Anaconda, but if you want to do it in your notebook, you can do this exclamation mark, and then you can do pip install Pycaret, and this will install Pycaret onto your PC. So that would be your first step. I am going to comment this out because I already have done this. And then once we have this installed, we want to go from Pycaret. And then the problem we're trying to solve here is clustering. So I'm going to get pycaret.clustering, and then I'm going to import everything using that star symbol. I also want to import pandas as PD, saving at the variable PD, and I want to import matplotlib.pyplot as PLT. I also want to import Seaborn as SNS, and I think that should do it for now, so I'm going to shift and enter that. It looks like we have a little bit of a mistake. Matplotlib.pyplot, so let's run that. And now we're good. So that is where we are. We're just bringing in and installing Pycaret. Just make sure you have it. And I am going to bring in the data set since I brought in my pandas. So I'm going to go pd.read underscore CSV. And then I'm going to bring in the mall customer. So now we can see we have our mall customer. We have the customer ID, the gender, the age, the annual income, and the spending score. Now there are some low code solutions to doing EDA, and you can do that if you like Pandas Profile or something like that. Will give you a lot of visuals and allow you to do a quick and easy dive into EDA. So I am going to just use describe first to get an idea of where my averages are. So we got an average age of 38, income of 60, and a spending score of 50. Looks like the max age is 60 and the minimum age is 18. So this is going to just give me an indication. Now we can also do our best to visualize some of these things. So one thing I like to do is I like to visualize the distribution. And because we brought in Seaborn here, we can look at the distribution. So I'm going to go and get SNS and then do the disk plot. This is going to give us the distribution. And all I need to do is pass in the column that I'm interested in. So age, and if I run that, you can see I can get that distribution there. Now this is a disk plot. This will give us this KDE and the histogram here. If you only want to see the distribution, I would go DIS and plot. And then you see we don't get that warning either. And this is because a lot of things get deprecated in Notebook. And one thing we can do is maybe we want to see the columns. So I'm going to go df.columns up here. And maybe we want to say, okay, I don't want to keep writing all of my different plotting features. What we can do is we can create a loop, and then I can just take the columns such as age, annual income, and the spending score here. And let me zoom out a little bit so you can see this. So I'm getting that age, annual income, and spending score. I'm going to put this in a list. So now we have that in a list. And then what I want to do is tell it to use this particular plot for each one of these columns. So the way we do that is we want to iterate through them. So I'm going to say for I in, so this is a loop, and we're going to loop through each one of these, and then we tell it something to do. So for each one of them, I would like a plot like this. And then instead of having age, I can get I, because I, when I go through each one of these, iterate through each one of these, it will produce a plot. Now, let me just show you what happens first. If I do that, we get the age, annual income, and the spending score all in one plot. So that kind of, and let me zoom out here, it gets a little bit nicer to see. We can adjust the size of those plots if we want, but I just wanted to show you how you can quickly iterate through those different distributions and get some easy, quick win visuals. So let's make a few more plots. Let's make a scatter plot. So we are going to document. Then we're going to use sns.scatterplot. And let me zoom in a bit. Scatter plot. And then I'm going to pass in the columns. So I'm going to do annual income. And then I'm going to do spending score. And then is it 100 in parentheses. And let's just escape an A and bring the columns here so we don't have to worry about it. We have annual income and spending score 1 to 100. I guess this will. And if we run this, we get this scatter plot. I'm going to make it smaller. So I'm going to do plt.figure, which sets the figure, pass in fig size. And let's pass in a tuple. I'm going to do this 5 and 4. And then it's a little bit smaller. Also, if we want to get rid of this, what we can do is at the top here, just so we have it running all the time, we can import warnings, because it's just warnings. And then we can do warnings dot filter warnings, and then we pass in the parameter ignore. And then if I go back down, and we get rid of that. And also you get this extra information here. If you put a semicolon behind, you will get rid of that extra information also. So I'm also going to want to see, this is the relationship between those two, but we can add some extra information. We can add the hue, and the hue will allow you to separate things categorically in Seaborn. So if I pass in the column gender and run this, you can see we get the breakup between those two. Of course, you could play around with colors and all that stuff, but we'll just leave that for now. And then, of course, maybe you want to see the same thing here, but with age. So I'm going to make an extra one here. So maybe there's a relationship between age and annual income. So I'm going to put age on the x-axis and annual income on the y. So there's our relationships that way. I also want to make a few more plots. We can make some box plots. So let's do SNS.box plots. Box plot. And let's zoom in a bit. And I am going to pass in age here. So if we run age, we'll get this box plot. Let's get our fig size here and come down a bit and add our fig size and run this again. And if we zoom out, we can see there's an age. We don't have any outliers. I also want to see if we have any annual income that is an outlier. Of course, we could make a loop and all this to just do all this, but I just want to quickly show you the plotting. So let's run that. So we do have one that's there. So what we can do for these box plots, we can add, for example, this is X. If we add that, shift and enter, you can see it stays there because it's running along the x-axis. If we do Y and run that, then we get it oriented that way. We can also add an X for our categorical. So if I put df.gender, we can find out who has that outlying income. Oops. I need to have an extra M there. And now you can see that outlier exists for female. And there is a slightly higher median for male than female. You could also quickly change this into a violin plot because they kind of run along the same logic. And we can see these violin plots here. And we can see that, you know, the distribution is a bit fatter around this amount when we get to the annual income as opposed to what it is in the females. There are other plots here like boxing plots. So you can play around with this a lot. I'm a big fan of, you know, a lot of these plots. So this income distribution, we also saw in our plot here that they have this kind of tail where the majority of it is here, and then we have some of the outliers. We can also kind of make KDE plot. I think would be very helpful for this visual. So if I do sns.kde plot, and then I pass in the annual income, and I run this, we get more of this density plot. And we can see the distribution of data. It's kind of normally distributed, but we can see it's a little bit skewed to this side. And the last thing I want to give you is a final plot. So we can use sns.pairplot. This is going to be a plot that runs over the total data frame. It might take a little bit of time, so let's let this run. And you can see what we get. Let me zoom out. Is we get those distributions that way, where we can see all of the relationships between the numerical and categorical variables. So we've done our EDA, and now we're going to set up the Pycaret model. And because we brought in all of those particular functions from Pycaret, we can just use setup and close that function in. We pass in our data frame, and then we can say that we want to normalize our data. So normalize equals true. And then we also want to ignore features. So if you remember, here is our data. We don't need the customer ID. It's not going to help with our clustering. So what we can do is tell it to ignore our customer ID. And then if I run this, you can see we get we need to add a session ID. So I want to manually add a session ID. And the way we can do that is go back up, and I want a session ID that we can have, because this is a random state, so this allows you to reproduce results later. So I just added 1, 2, 3, and you can see that session ID changes. You can see we have our original data set and our transformed data set. We know we ignored our customer ID. That's why you see that missing column. We get our numeric and our ordinal features. The ordinal feature is going to be our gender, and then we have numeric and categorical, and you can see all the other information here. Now that we've set up that API environment, we can take a look at the models that we are interested in. So this is a clustering package. So if I type in models, we should do that under this heading. So I'm going to escape and B. And if I type in models and close that function off, shift and enter, you can see we have quite a few different clustering algorithms. And they all have different advantages. In what I wanted to bring to your attention, all of these are coming from scikit-learn. And we can do all of this manually. But I'm going to use the k-means algorithm. So I'm going to go here, and we can create a model. So you can see the functions are quite easy. I'm going to go create model, underscore model. And then I just pass in the model I'm interested in. I'm going to use that k-means algorithm. I do encourage you to read up about these algorithms, because depending on the type of data and per use case you have, it may depend. So I'm also going to name this our k-means as a variable. So I'm going to shift and enter that. And let's see what happened. Oh, create models. And it's model, not models. So shift and enter. And then we can see it initialize with this information. Once we have that model and we saved it as this variable, we can take a look at it by printing the model. So print k-means, which is that variable that we called it. And then you can see we have 4 clusters in that random state, which is a session ID. And that will give us a indication on what is going on. Now what we can do is evaluate how a model is created and optimized. So if I create this and I put k-means and I evaluate the model, what we get is the actual pipeline. So you can see, and I hope you can see this, we started off with that raw data. We had a simple imputer, so if we had any missing values, it imputed the value with simple imputer. And it seemed to run twice. We have an ordinal encoder, which probably ran over our gender. And then we have a standard scaler. And then we ran the k-means algorithm. So what does that mean? Let's go back up to our data, just take a quick look. We can see that we have these 2 ordinals that we probably have created. And then we have our income, and we wanted to scale these numbers so they are on the same scale. Now, these are pretty small numbers, but sometimes you could have things in the thousands or millions, and then have things in single values, and you probably want to scale that. So our pipeline already did that for us with standard scaler. So that is our model that we were able to, let me just zoom out a bit, okay. And we definitely want to make sure that we can evaluate how this model is working. So these interactive buttons here show us a bit of information. For example, if we wanted to see how the clusters were derived, we have 4 clusters. We can use a silhouette method, and we can see the average silhouette score here. And an easier one to see is the elbow plot. So usually for the elbow plot, for us to understand where we should choose the cluster, you see it's right around 5. And we chose 4, the model chose 4. And it's usually where we get less benefit. There's a distribution plot to show us those clusters, and which has the number of clusters in it. And then, of course, we have a distance plot. And there's quite a lot we can look at. There's a 3D cluster. It's very finicky, because please remember, let's see, that we have 4 clusters across different dimensions. So we added as many dimensions as we can, and then we created this 3D plot. So it's kind of hard to see. And if we go back down to our pipeline plot, you can see the pipeline there. Now, we also have to understand that when we created our scatter plots, let me just go back up. We only have 2 dimensions to work with here. So we have to decide which 2 dimensions are here. But we can use PCA to get an understanding, because we have all of these different dimensions. We can reduce all these dimensions down to 2 and run a PCA plot, which I will show you in 1 minute. So if I create a space here, and first I need to assign those clusters to my new data frame. So I'm going to use k-means underscore df, and then I'm going to say assign model, and I want to assign that model to my new data frame. And then let's take a look at this data frame, k-means underscore df dot head, and let's run. And then you can see what happens is we have our original data with our cluster. So if we plot the model, we can use the plot model function. And that's going to use something called PCA that reduces all these dimensions into 2. And I'm going to pass it k-means, shift and enter. And you can see we get this 2-dimensional plot. That's interactive. And this is probably built on Plotly. And we have 2 dimensions, which is created by an algorithm, and then we have our clusters situated here, and you can kind of see how they were chosen. Now that's different from us choosing spending score and annual income and then applying our clusters. Lastly, what we want to do is save our model so we can escape and B. And let me put another one. And if we want to save our model, we just type in save underscore model. And then we pass in k-means, which is the name of our model. And then we give it a name. And I'm going to call mine trial k-means. And this is going to save this as a pickle model that we can bring into Power BI and other applications. Okay, so here we are. I have my Anaconda prompt open, or whatever prompt you are using, but make sure this is where your Python is. I'm using Anaconda. So first thing I want to show you is you are probably not going to have a bunch of environments installed if this is new for you, but I wanted to show you all the environments that I have installed. And you can see I have several versions of Anaconda installed. And if you can see here, this is my base environment, which is also indicated here. This is probably all you're going to see if you've loaded in Anaconda, only one environment. But when you're using a bunch of new different solutions, sometimes you will create an environment. So you can see that I'm using Anaconda 3 for that base environment, and that's going to become important when we go into Power BI. And I also want to show you how to launch Power BI. You can also do your installs here. So if you want to do your pip install here, you can pip install Pycaret here, as we did in the notebook. But in this, you wouldn't use the exclamation. You would go pip install Pycaret, or you could do conda install Pycaret like this, and it will install all those packages. So the first thing I want to do is show you the right way to launch Power BI from this prompt to ensure that you're in this environment so we don't have any conflicts. So what I did is copy my Power BI path, and I just copy and paste it here. And when you do this, you are going to open up your Power BI instance from your notebook that is in that base environment. So if I click that, what's going to happen is Power BI is going to start to open up in a new window. And I have two screens here, but I'll show you when it loads up. So what has happened is I gotten in Power BI here. I'm going to open this up. I'm going to take this file off here. And now I'm going to show you, I'm going to go to File. I'm going to go to the Options. Go to Options, and then you see Python scripting, and you can see your Anaconda here. So you can see when I had that base environment open, and let me see if I can pull it up again for you. So when I had that base environment, we can see Anaconda 3 is there, right? So make sure that you are using the right version of Python, and then you should be able to have no problems there. So let's get our model loaded in. So I'm going to get rid of this. We need to bring in our data first, so let's get rid of this. I'm going to get my mall data, and actually I need to bring that in as a CSV. So I'm loading in my mall customer data. When that window opens, you can see here's what we have. I'm going to go over to transform. That's going to bring in my Power Query menu here. I'm going to open that up some more. I'm going to go over and duplicate this because I just want to have one to use Python on and one to work with. And then what we're going to do is bring in that model that we saved. So let's go over to transform here and then go to run our Python script. And what I am going to do is import pandas as PD. I don't think we need it, but I'm just going to install it. And then you can go and copy this and paste it from your notebook, but I am going to say from Pycaret.clustering. I'm going to import everything. This is the first step we did. Now what I'm going to do is I'm going to use a new variable. I'm going to call this our, let's call this our k-means data frame as we did before. And then I'm going to do the load underscore model. This is a function we haven't used yet. And then I am going to get that file location, which should be in your root directory. So you got to know where you're installing it. And I am just going to copy and paste mine here. And you can see I have that trial k-means. And then I am going to use that. Oh, and this is just, let's call this our k-means instead of k-means df because that could confuse us. So now we have our model. We loaded our model. And then we're going to have our new df. How about that? And then we will use predict model. And then we will pass in our k-means. And then we will pass in our data equals data set. So you can see what it says here. Data set holds the input. The input is that CSV. So I'm just passing that in. And we can see here in the Anaconda. And if I don't have any issues, this should run. So you can see what we have is these new tables. We have that loaded model. And that loaded model has all the features in the pipeline that we install. I'm going to open this model up. This table up. And we should get our clusterings and everything we need. So there we have our clustering. You see we have our clusters. We ran that machine learning model with the Pycaret API directly into our machine. And all we have to do is close and load this. But we'll do one more transformation possibly in the next video. Okay, one additional thing I would like to do is I would like to create some bins for my age. And we could do that, or age, or any one of our columns. And the way we can do that is we can go back into our new DF, and either we can start by running the additional Python code in here, or we can create a new Python script. I don't know. I like having the steps here. So I'm going to go back over and go to transform, and I'm going to run an additional script. And we know we have the dataset variable. I'm going to call df equals dataset because I don't want to continually write dataset. And then I'm going to import pandas as PD. And then what I'm going to do is I'm going to use a function called cut. And I'm going to create a new column called age bins. And then what I'm going to do is bin that continuous data by creating 5 or 6 bins. So I'm going to go to pd.cut. And then I am going to pass the age in there column. And then I'm going to say, hey, give me 5 different categories. And then I'm going to do a few more. So I'm going to say, let's maybe do an income bin. So annual income. I might use this one, I might not. In K, and it looks like this sign. Hopefully. And I'm going to create a bin there also. And I'm going to pd.cut. And then I'm going to get this column again. And actually, we need to give it a new name. I don't have it as a new name. And I'm going to give it 10 bins. Probably don't need that many. And then I'm going to call it income bins. And make sure it's And let's see if this actually runs, and let's spell income right. Let's double check and put a space. And let's run this. Okay, so we get our DF table back. We're going to expand that. And we should have 2 additional columns. So then we have these bins here. So I'm going to close this and let's just create a very simple dashboard. So I've applied, it's going to run. We have that additional table here, which is 2. You probably want to give it a better name. Okay, so that ran. I'm going to take this table and I'm going to just create some very simple visuals. So I'm going to just create some averages. So I have sum of age, turn that into an average. And I'm going to make 3 of those for our 3 columns. So I just copied and pasted that. And there we go. And put that all on the same level. Then I'm going to get my annual income, turn that into an average. I am also going to get the spending score, turn that into an average. I'm going to use clusters here and bring that in, turn that into a filter by going over to the filter. So then we have this where we can get those different clusters and we can see that average change. Then I want to get those bins that I had. So I want to get the bin here and then turn that into a bar chart. And we use this, oops, wrong one. We turn this into, oh, sorry. There we go. So we have this bar chart here. And we have these bins. And then I'm going to make one more. And then I don't want to use age bins. I want to use my income bins. So income. And if you remember when we did that EDA, we saw that that income was trailing off. Now, you can definitely do your Python visuals here if you want, and I'm going to show you this. But I just wanted something simple to bring out. So I can definitely just look at all of these. So I'll show you how to make a very easy Python visual. What you're going to do is click Python. And then you can see you can enable the Python script. And then you need to build the data set by bringing in the columns that you want. So I'm just going to bring everything in. And what that does is create a table in a sense. And then I am going to create one of those violin plots. So let's import matplotlib.pyplot as PLT. Let's import Seaborn as SNS. And then let's say df equals dataset, because I don't want to keep writing dataset. And you can see here it has a dataset, it dropped the duplicates. And then I am going to say sns.violin plot. Let's create a gender plot. So we can do for X, I want to use the gender. And then for our Y, I want to use, let's use income, writing it over. And so I'm going got to write income to make it simple because I know. So there we go. And I should be able to just leave it that way, hopefully. And now that I have this, oh, and then we need to write plt.show anytime we run these. Let's see if this works. And you can see it cycling through. And we have an issue. Oh, I have an error. You can see it says name error D. So it should be DF. Let's run it again. So always read your errors because they will point you in the right direction. There we go. So we have these plots. So let me close these. We probably need to change the title of this. And each time you run this, it's going to get bigger. So if you stretch it out a bit and you rerun the script, it'll get bigger. It's not a very pretty plot, but you have access to a bunch of different plotting. I'm going to pull this down. And then we also probably want to change this to horizontal. So I'm going to go to the slicer settings, and I'm going to turn that into a tile. And then I'm just going to pull it across here. And then we have our clusters. Probably it would be cool to add another tile here. I'm going to copy this, and then I'm going to go get gender. And let's go over, and let's replace this with gender. We'll probably make these a bit smaller. And this is my ugly dashboard, but I'm sure you can spend some time on this and really jazz this up and make it very interesting. Now, the Python visual takes a little bit of time to load, so you can see it cycling through. So it's not the best way to do that. So I like using the visuals from Power BI a little bit better. But all of this is going to update because of the script needs to run so you can see it running. And it will reflect what you are picking. But that's how you use a machine learning model in your Power BI notebook. Okay, so let's just quickly finish this dashboard. I'm going to make a little bit more room here. And we're going to keep it simple because we're going to be building dashboards that are a little bit more complex than this. I'm going to copy everything by hitting Control A. Well, not copy, but pull everything down so I can get a nice heading. So I am just going to go to Insert. I'm going to go to Text Box. And then here I'm just going to write our mall clustering dashboard. And now I am going to just go in and make that bold and make that a lot bigger. And we can just bring that over. I'm just going to get a line from Insert Shape, go to Line. Then we get this little line. And I'm going to depress it a little bit and just pull it under this section. Then I probably will like to split the other sections up also. So we have our controls here. So I'm just going to hit copy and paste there. So this will allow them to see the controls, bring these visuals down. I'm going to get rid of the title here. And what we can do is we can separate these also. So it's a very simple dashboard. But what we can do is, we can definitely change the colors of our different controls here. But the thing that sticks out the most here is this color doesn't match this. So let me show you how to add the color here. So what I'll do is I'll go over and click on one of those color bar charts, go over, Then we're going to click on make sure that's highlighted. We go to columns, and then you go to more because you can see the color is selected. Then we will get this hex color. Go over to your plotting here, and then we are going to open it back up because it's a Python. And then in the function where the plotting is, we're going to write color equals, and then in parentheses we add that. Then we run it here, and that should change the color to match these colors. So as you see there, then we have everything that matches. Of course, this is the simplest dashboard we want to make. We can definitely alter different colors. So, but right now, let's leave the dashboard as it is and move on to building others. So let me just show you how to do this from scratch. We're going to import pandas, numpy, and sklearn .cluster, and then we're going to import the k-means algorithm. Then we read in our data with the CSV. Now let's prepare our data as we did before, prepare the data set. So first thing we want to do is drop that customer ID. And then I'm df.drop. And we'll push that in. And then we will say how we want it dropped. We want the whole column dropped, so we just say axis equals 1. And then I'm going to save this as df2 just so we can keep track of it. And now remember we wanted to change these categoricals, so I'm going to change the genders. I'm going to do first, I'm going to just use pd.getDummies, and getDummies, I'll show you what that does. And I'm going to pass in our whole data set, df2, and then I'm going to say drop first equals true. And let's just show you what this looks like. So what we get is this gender, whether they're male or not, and we get 1 or 0. So let's call this df3. We'll just keep that for us, and that's going to be our categoricals. And then let's scale our data. Oh, and we didn't bring that in, did we? So from sklearn.preprocessing, we want to import standard scalar. So we keep track of everything. Standard scalar. We'll call it scale, and we instantiate that. So, and we're going to say scale dot fit transform, which is going to transform everything in our df3 to a scaled format. So I'll show you what that looks like. So you see what we have here. Fit transform, and I'm going to call this df4. So now we have that data. Now what we want to do is call that k-means for our model, or just call the model. And then we're going to do model equals k-means. And then what we're going to do, we know it's 4. So we're going to do fit. Well, let's pass in our information here. We know it's 4. So what we're going to do is in clusters, we're going to pass in those 4 clusters that we know. We're going to also give it a random state. And we'll call it 1, 2, 3. And actually, let's just do it in multiple steps so you can see. So there's the model. And let's fit the model to our data. So what we're going to do is we use that model, and then we fit that data that we have in df4. And then what we see is we get these clusters. You get this warning just because things get deprecated. But you can see here's a k-means algorithm and the random state. And all we need to do now is get our clusters. So we're going to use model.predict. We pass an ID of 4, and we get those clusters. And all we need to do is add that back to our original data frame. So df equals cluster equals model.predict. And then if we look at df.head, you can see we have the clusters and everything we wanted in the original one. Now we'll get a little bit more in depth later on how to kind of work on these and when we should do something like a Pycaret and when we should do a raw and from scratch. Okay, we're going to be solving a business problem with regression, where we're going to be predicting the selling price of a car. And we're going to follow similar kind of format from loading our packages, setting up the environment, model comparison evaluations, creation, predictions, and saving our model. So let's get started. I'm going to make a space here, a couple spaces. And what we're going to do is from Pycaret .regression, we're going to import everything, and then we're going to import pandas as PD. We're going to import Seaborn as SNS. We're going to import matplotlib, pyplot, and let's get our data set. So let's run this, and let's also get our data set. Oops, pyplot as PLT. There we go. Let's run this one more time. And then we're going to use that pandas variable to read in a CSV. And we're going to read in our car data CSV. And let's look at the head of the data. And also look at the info. So let's run both of these. So here's our data. You can see the columns. We have the car name, year, selling price, present price, kilometers driven, the fuel type, seller type, transmission, and the number of owners. Then we have our column here. We have 301 entries. We have 9 columns. And if we wanted to do visualization, how about we use a profiler? So here I'm going to use pip install panda_profiler, and I'm going to run that. It probably already have that installed, but let's see. So you can see the requirement is satisfied. So I'm just going to get rid of this and just turn it into a docustring. And let's use one of the profilers to do our visualization at the moment. So let's go back up to the beginning where we loaded our packages. And let's say from pandas underscore profiling. Let's import profile report, I think it is. And let's run that. Oh, a little bit of a issue there with an extra O. And you can see we have this as parts are going to be deprecated. So I don't want to see all these big warnings. So let's import warnings and add filter warnings. And let's use ignore. And then if I run this again, you can see the warning goes away. So let's use our profile report. We're going to use that inbuilt function. And we're going to pass in df. Let me just show you what happens when you run this. You can see it starts analyzing your data. And then we get this report here. So you can see the number of duplicate rows we have. We can look at the different variables to see what's missing and the correlation. And then what we're going to get here is different visuals that you can use. So for correlation, we're going to go over doing this correlation very quickly, manually. And then missing values and a sample and last rows and duplicate rows. So, oh, we see this duplicate there. So this is a profile report if you want, where we can see quite a bit of information. We can do all of this information with the interactions. So this is one way you can definitely, profile your data. I'm not a big fan of using these. It seems like information overload. So I am going to just comment this out for you, run that again. So that is there. So we are going to start preparing our data in the next video, where we can look for some correlations and things of that nature. So because this is a regression problem, I'm very concerned about the correlation. So we can visualize correlation with a seaborne heat map. So we can just run the correlation function, and I'm going to add a heading here for, let's call this EDA. So let's call it heading, and let's call it EDA. And if I run the correlation, what I'll get is a correlation between the numeric values. And I can wrap this up in a SNS heat map, which is your seaborne heat map. And we can add some parameters like annotation equals true. We can change the color map. So CMap, I'm going to change that to cool, warm. And what else do we want? I want to add some line width here. And I'm going to say line width is 0.5. And let's see what this looks like. So we have this correlation matrix. And it tells us what is correlated with the selling price. Now, if in all of the correlations, so if we have things that are highly correlated, we may want to remove them. For example, if I would assume if we have the selling price and the present price, this is really going to be the major predictor in there. We can leave it for the moment, but we should definitely see what is going to cause the most correlation as an indicator for what is going to be very effective in regression. Now, I'll show you another way we can visualize this just by seeing how things are correlated with the selling price. And we can do that by passing in these double brackets next to the function here. And if I shift and enter that, you can see what we get. We can see what is highly correlated with that. We could also, after we do this, we want to sort the values, and then we want to say by selling price, underscore selling price. And let's run this. Looks like we missing it here. A little bit of an error. And you can see what we get is, and we can always kind of break this up a bit so we can see it a little bit better. So I'm going to put an escape function here. And now we can see this a little bit better. And anytime you have a comma, you can also break this up. So we can see the things that are going to be highly correlated is with selling price is, of course, selling price and then present price. If you wanted to have this ascending, you could definitely change it when you sort the values here and say ascending equals false. So that's one way for us to see how things are related. And another great thing to do is I like to make this smaller. So let's change the figure and let's fix size and let's add a tuple 5. And let's try this one. There we go. So I kind of like when it looks like this, when it's long, and you can see that correlation there. So we can see that the present price, year, and the kilometers driven are all going to be things that are correlated with the selling price. So in the other EDA, we can depend on our other normal visuals. One thing I'm curious about is the selling price. So I'm going to use a KDE plot. And let me zoom in a bit. And I'm going to pass in DF and then the selling price. And then I'm going to put shade equals true. And then I'm going to run this. And then we can see we have some cars in this area that are trailing off. So we can see the data skewed. And we can assume that this is our outliers. Of course, we could change that into a box plot so we could see how many outliers we have. So I'm just going to just copy and paste this here. So escape and B. And then I am going to turn this into a box plot. Oh, there's no shade in box plot, so we need to get rid of this. And you can see we have that box plot. I'm a big fan of having it skinny. And so I'm going to take this and look at it this way. And then I'm changing it to Y. And so now I can see that we have quite a lot of outliers in there that could skew how our model predicts our data. Okay, let's begin with our model setup. So we're going to do setup. And then for what we're going to do, we're going to pass in our data, which is DF. And there's a couple other things we need to do with this particular model. We need to identify what the target is. So I'm going to write target. And our target is the selling price because this is what we're trying to predict. Also, we want to make sure that we have a certain amount of data that is being in the training size. So we want to train on 70% of our data. So I'm going to write train size 0.7. And then I'm going to also, let me put 70 because it's easier to see. And then also I'm going to do a session ID and I'm going to do 1, 2, 3. And let's set this up. And we can see that everything has been set up. We have our process. And now what we can do after we set up that environment, we can start to compare all of the different regression models. So if I do compare models and I run this, what we're going to do is get a collection of models that we can see the performance on. So we can see this is slowly loading. And what you're going to get is a collection of metrics to score the model, such as mean absolute error, mean squared error, root mean squared error, R squared, and RMSLE. And so what we are going to do is choose a model based on our criteria. So usually when you're doing a linear regression model, R squared and other metrics are used to determine what is the best model. I can already see that linear regression and ridge regression are at the top, and this is why they have been pointed out. I'm assuming ridge regression is doing slightly better than linear regression just because we have a lot of features in our model. So this is a good way to choose these different models, and you can definitely research these models because there are benefits to using them, but I'm going to go with the linear regression model. So now that we have that, you can see it chose ridge here as the best, but it's barely discernible between the root mean squared error and the R squared. So I'm just going to keep it simple. So we have compared our models, and now what we want to do is get our model. So I'm going to say model equals create underscore model. And then I pass in the model I want to use. So it's LR, which is indicated here. And I'm going to run that. And what it's doing, it does a tenfold validation where it takes 10 different sections of our data and runs the model on those randomly selected to see how well that model does, and then it takes the average here and the standard deviation. So we can see that this still does very well at that 0.86 R squared. Then what we can do is we can also use a tuned model. So there is a function called tune model. Now for this, I'll show you how it works, but for linear regression, there are not a lot of hyperparameters or things we can tune. But all we would do is pass in our model, and I'm going to call this our T underscore model for our tune model. And I'll run this. And what that's going to do is look for some hyperparameters or things we can change for that model. But you can see we get the same results. If we were doing something that had a little bit more sophistication to it, we would be able to tune that model. But for our purposes, we don't have anything that is needed to be tuned. Now let's evaluate our model. So let's do evaluate the model. And if I run that, we get our pipeline. Back when we were talking about hyperparameters, you see there's really nothing that we can really change. We can get a residual plot to see how well we did comparing the predictions. And then you can see we really did well on the training, but we didn't do so well in the test, which could be a concern. We have our prediction error here. So we can see that R squared doesn't really do very well because we have a lot of outliers out here that may be affecting our data. So that might be something we want to remove or find out why we have those outliers. But feature importance, which shows us which of the particular features are most important. Now we looked at the correlation between the numeric, but we can see that car name and seller type are some of the things that were really dependent on driving that price and accuracy. So there is a lot of different particular plots we can use, and we have a learning curve. So this is a really good plot, and I'll show you some ways to plot this later. Now what we can do, we can get our predictions. So I'm going to press escape and B, and we want to be able to get those predictions. So I'm going to get that final data frame, just call it final DF, and then I'm going to do predict model. And then I'm going to just pass my model over to that. And then let's get the final DF, the head of that data frame. And we run this, and you can see what we get. We get the scoring metrics here. You can see that R squared dropped quite a bit. So you might want to think about doing a ridge. So what's happening is our model is really good at the data it learned, but the testing data, so the data that we held out, it is not doing so well. So we may need to go and select another model to get a better R squared, or what we need to do is go back and think about some of the features that we may need to remove. But there's a whole host of things we can do to get a better model if R squared is what we're looking for. And then we can see we have our prediction label here and the selling price for our vehicles. We can see that we're not necessarily spot on. So there are things we can do to improve that model. I think one thing would be to possibly remove the car title and also remove some of the outliers and play around with that underlying data. And lastly, we can, well, not lastly, but let's look at plotting. So the plot model, this is very good because we can indicate what plots we want with this model. So I'm going to press Shift Tab, and what you'll see in this Jupyter Notebook, if I click it open, we get a plot based on what we're giving it. So this is going to be the residual plot, but what we can do is add other plots here, such as the learning curve, the validation, the feature importance. And I always think that feature importance is a good one to add. So I think it said feature. Let's shift and run that and see if that's correct. Yep. So we get that feature importance. And this is stuff we can add to our particular notebook. Now let's save our model. So I'm going to press Escape and B. And I'm going to do save underscore model. And I'm going to give it a name. I always say trial reg. And I'm going to run that. Oops. Oh, and I'm missing my model name. Sorry. Model and trial reg. And now we can see all of those particular pipeline and everything has been saved. And now we can take that model and import it over to Power BI. So just to be clear that about the feature importance, we plotted this. This is not the same as the coefficients from your linear model. Tree-based models such as decision tree and all of those will give you feature importance, or ensemble models like XGBoost. And these are not the coefficients. This is a different method. But you can get the coefficient from your model. I'm going to go down and show you. Let me make a few spaces. And let's get the coefficients. So let's say get. Okay, so a model object here, model, has coefficients. So we just put coef underscore. And if we shift and run that, we get this list or array of different coefficients. Now that doesn't really help us because of course we want the feature names, and now we also have features in name, feature names in. So if I run this, these are all the feature names. So what we're going to do is combine those two with zip. So we can do zip, we want the feature names and we want the model. And let me zoom in so you can see what I'm doing. Model.coef underscore. And once we zip those two arrays or list, we also want to enrapture those into a data frame. So because all we get from this is a list object, so if we enrapture that in a data frame, and let me just show you what it looks like. So shift and enter. Now we want to make sure we add the right columns. So we can add columns to our data frame function, and then we just pass in a list. So these are the features and the coefficients. All right, and then if we run this now, shift and enter, you see we have those listed. Now this is going to give you the magnitude of what is most affecting your linear model, and you can see that these are the features. We can save that as df. We better save that as coef because we already have a df, and coef.head. Oh well, we can run the whole thing because it's quite small. And there we go. Now we can definitely bring this into our Power BI notebook, and let's do that next. So we have our Anaconda prompt open, and what we want to do is launch our Power BI notebook. So we're just going to copy and paste our path where our Power BI is installed, and it's pretty standard on everybody's PC. As you see, this is going to load Power BI. Once it's loaded, we're going to get our data. So we bring that in. We're going to go to transform. We're going to duplicate our data set just to have one that we have our code on. So I'm going to call this prediction. And there's a couple things I want to do because I don't want to try to reproduce the same visuals in the Python's visual because it's too much processing and data. So we're going to create those visuals within our data, and then we can keep them interactive in Power BI. So first, let's get our Python script. We go over to transform, run script. Then we're going to import pandas as PD, Pycaret dot regression. We want to import everything. Then we want to get the model equals load model. And I sometimes need to put in the whole path just so this will work. You might be able to just put in your name, but it seems like I'm having some issues. So I just copied the path where my file is, and I just need to change these slashes to the other direction. And you can see we're bringing in that pickle file from our reg. It's supposed to be trial, but I spelled it wrong. Now what we want to do, we have that model that we're bringing in. Let's call this fine. We'll call this our prediction df predict model, and then pass in our model. And we also need to pass in our data. So our data equals data set. And you can see this is what your data is called, data set. And this should give us your prediction df. Oh, and let's get rid of the pickle part because it can interfere because it's going to automatically understand what that file is. So this is the path that I'm bringing in. You might be able to just get away with this file name, but I would definitely try both. Let's see if we have any errors. Should be good. Let's run it. Nope, we have something. Import pandas. We have a spelling mistake. And it should be as. Let's see if that runs. So it ran. We get the prediction df table, and we have our prediction labels. Now, the one thing I want to do is get the residuals. So I'm going to add another column, and I'm going to do custom column. And then I'm going to get the selling price minus the prediction price. Show the direction. So let's change that to selling price. And I'm just going to grab that here. Then now we should be good to go. So we can see the direction whether we overbid it or underbid it. So yes, now we're in good shape. The next thing we want to do is get our coefficients. So I'm going to create another duplicate of this. And then I'm going to go back over to our file that we created, that Python file. Get our coefficients. And go back over. And then we're going to call this our coefficients. And it's going to run again. So let's go to the Python script. We're going to open that up. And then we're going to get our coefficients with this code. So we should be able to bring that in also. And we let this run, and then we can now be prompted to choose which of the tables we want brought in. So you can see how long it takes to run on its own. So you don't want to have this running as a script visual. So you want to do all this in the back end. So now we have our coefficient table. We're going to open that up. And yes, we're going to replace all the other steps. Okay, we have our coefficients. So I'm going to close and apply this, and then we can visualize what we're doing. So we have some options here. We can definitely we want to display our coefficients. So I'm going to get the features and coefficients and just bring both of those in. It will probably be better to turn this into a bar like this, and we can get an understanding on what impacts our overall prediction positively and negatively, and also the magnitude. So as the number of owners increase, so does the negative coefficient there, which makes sense. And then the car name is still super influential. Present price is going to be a good indicator, and the year. So as the year gets closer to the present year, it leads us to have a higher point. It's probably be nice to turn this into a conditional highest value and lowest value. That is fine with me. And that doesn't really do much. So let's go again. And let's turn this color into red. The count of features, we need to make sure that it's actual coefficient. There we go. And now we can see that different color there. Next, what I want to do is we have our coefficients. I want to bring in the prediction, which is our predicted label, and our selling price. And I want those to be a scatter plot. I don't want to summarize either one. And then we can kind of see how that model works if we go over and we add a trend line. And we can see how things adhere. So here we do a very good job at predicting in terms of our model, but we can see we have some outlying values out here that cause a lot of havoc. And then I'm going to make another visual. I'm going to get the average, residual. I'm going to turn that into a text. Let's do median selling price. For example, I also would like to go back over to our data here. And I want to get a category here where we have our predictions, and I want to be able to create a category on our residuals. So I want to know if we overbid it or underbid it. So I'm going to go to add a column and conditional column. So I'm going to say if the residual is less than 0, we can say we underbid it or underestimate it or over predicted or under predicted. And then else, actually we don't need this one because let's just only put 2 category, else overbid. And we can see there, so let's go ahead and close that. I'm going to throw this bid type in here as a donut, and then we just see if we overbid it or underbid it, and that will give us some indication. We can definitely make this look a lot prettier, but I just want to show you the visuals. Now, You might be thinking, hey, let's run everything. Let's do some of those fancy charts in the script editor. It is going to run really slow because remember the model is predicting and doing all those steps if you copy and paste the script inside here. It would be nice to maybe have a correlation matrix in here, which we can do. So let's do a quick one there. We're going to get, we'll get all of our numerical features except the predicted label and selling price and year. And remember, we can just do our chart over. So I'm going to say df equals dataset because I don't want to keep writing dataset. And I'm going to do first, let's import our packages. Import pandas as PD. Import matplotlib .pyplot as PLT. Import Seaborn as SNS. And then I'm going to do, we're bringing in our data set, so change the data set variable to df. And then I'm going to, let's say, visualize. And then we're going to do SNS.heatmap. And let's pass in df.corr. We want that line width, I think this is it, to be 0.5. And we also want it to be annotated. So annotation equals true. And we make sure this is a function. And we also need plt.show. And if we don't have any errors, this should run. Let's make this a little bigger and let's put it here. Okay, let's run this. Select to, oh, we need to enable the visual. And then let's see if it works. Oh, and we should also do CMAP is cool warm. So it matches CMAP equals cool warm. So it matches the rest of our dashboard. So you can see it running here. So now we have this kind of funky looking dashboard here. We have our selling price, our median price here. Might be interesting to see the prediction price. The median prediction price. We go in the median. So we can see we definitely have quite a bit of an overbid if we look at the median. Here's our average residual. So there's a lot we can do to make this dashboard very snazzy. So okay, now we can see all of the different features, and we should be good to go. So this should be, if we clean this dashboard up, it could be something very interesting. Of course, we want to make a filter. Let's put one more here, and I'm going to make this dashboard slightly bigger. The height I'm going to put at 920. And then I'm just going to copy all of this and bring it down. Okay, and what else do we, maybe we get the total number of cars for one. And we know we have 300 cars, and maybe we can put a few filters. For example, the fuel type. We know we can split our data up that way and kind of see how the whole model runs. This will also run, and it's going to take a long time. So we need to be aware of that. You can definitely set this up where it's not running by using the edit interactions. And then maybe we can also do the bid type. And one more. Let's use the selling type. So there's a lot of information we can get. We can definitely build this out to be a little bit more informative. But I hope that shows you the power of what you can do. Okay, let's spend a little bit of time improving this dashboard. So I just duplicated the page here. And what I'm going to do is I am going to change the dashboard size by going to canvas settings. And then I am going to make this taller. I'm going to make 1120 maybe. And now you can see that's a little bit taller. I am going to just copy everything by pressing Control and then copying all my visuals. And then I'm going to pull these. It's always hard to pull some of these down. So I think I'll pull everything down by just pressing Control and Alt. I like how this is displayed, but I want these to be more in a row. And I think having the controls over to one side makes make a little bit better sense. So like right over the main visual, which is going to be at correlation. And then I am going to stack these on top of each other for the selling price. And I like the way that looks. I'm going to make this a little bit more of a centerpiece. So if you pull it out more, and then once we run this again, it should improve a little bit. So I can go over and I can click here, and then I can click run, and it should get a bit bigger. Yeah. So now that is the centerpiece of our dashboard. I still think I might need to make this slightly bigger because I want to add a title. And I don't want to adjust all the... So I'm going to click into the white space, go over, canvas setting. I'm going to make this, let's say 11.9. Let's make it 1220 for our height. And we can see things went on, so I control and pull down. Just grab one of those things. Okay, so now I want to put these here. And I want to definitely change the size and the color. So I am going to go over, go to category value. I'm going to change that to this Sugoi bowl. And then because they're all the same visual, we can kind of change their properties. So the size, I want the width to be a bit wider. And then I am going to also change that positioning so they're all on the same horizontal position. So I'm going to put 71. And now they're all together. And I am actually going to put a separator here. I'm going to get rid of the title on some of these. So this, or I don't like the title, so I'm going to turn that off. Plus it's just in the way. And I am going to change the colors here. So I'm going to change the selling price. I'm going to change this to a blue. So general effects. And I'm going to change this to this blue. And of course I'm going to change the color to white. I am going to change this one to a slightly lighter blue, and I'm going to change this one to a slightly lighter blue also. And then I'll change this one to super light. Okay, so now I want to change the values in these two to white. So I go over, I go to call out value, and then I just turn these into two white features. And I even might want to have those slightly bigger, but I kind of like the way this looks already. And then I am going to pull my visual here up. This one's hard to pull up. There we go. And there we go. And there's a lot of white space there. So I'm going to pull these down a bit and then just have that running over those. And then I'll add, this is a problem, this one runs all the time. I'm going to pull both of these up to be flush with this, and I'll pull this one to be flush with this. Then I'm going to add some dividers. So I'm going to insert, I'm going to go over to shapes, I'm going to go over to line, and then we get this line here, and I'm going to pull this in like that and just make that super skinny. And maybe we have a little bit of space. And now what we're going to do is we'll duplicate this and we'll pull this one here. And now I want to be able to call these areas a couple of different things. So make sure this is lined up. Yep. Still need more space because I still want to add a title. So I'm going to start by getting some shapes, and I'm going to go here. And I'll add this to my dashboard, but I want a different color. So I go to General, I go here, back, and then I go to Effects. And let's go Style. Yeah, Style. Then I'm going to choose this dark blue here, and I'm going to choose text for my title. So I'm going to put on, and I want that to be white. So I'll call this my main metrics, and I'll make this a bit bigger. I'm also going to make that bold, and then I'm going to go here, and I'm going to call this model details. So I go back over General, Effects. Where was that? Style, then text, and then I'm going to call this model performance. I'm going to actually make these bigger so they kind of overlap. So I'm going to go back over General, and I'm going to go back over this tile. There we go, properties. I'm going to make the height 150. And I'm going to make these 225. Yeah, that looks a little bit better. And then I want them to overlap. So we need to move this to the back, as you see. So I'm going to go to, I believe, Format, and then I'm going to send send to the back. There we go. And I actually want these to really overlap. So like this with just a little bit of a gap. So I'm going to do that. We need to definitely make sure the titles are visual so we can see them. But we still need to make this bigger because I don't have enough room for my title. So let's go back to our canvas settings. I'm going to make this even taller. So I'll go 13. Oops, 1, 3. And that looks like enough room. Maybe more. There we go. And now we can also alter some of the visual here, but I think I'm okay with that. So let's use the titles here and here. We want to make those white. For the category label, we want to make sure they're white here. And I want to make sure these are super dark. So let's go and make those dark. And now we kind of got a better thing. I think it would probably be better to have something in the background here for these maybe. So I am going to get a shape. But first, I think it might be good to change the title on all of these. So you definitely want to change the title here on all of those so it's something that really pops out. And then I'm going to go copy this shape. And I am going to bring this here, but I'm going to make it bigger. And I'm going to pull this all the way over. Then we can shape the text the way we want. Style, text, and then we can say it's not center. We want it that way. We can put a little bit of extra space there. So we have our model performance. Now, one thing I do like, I still need to I'm going to bring these down just a tiny bit more. It's always good to put a narrative here. So with some text. So I'm just going to come here and put a narrative and say what we're doing. So I'll speed this up. And then I'm going to just move this from the back, go to formatting, send to the back. Let's make sure they can see everything. Still needs a little bit of room to come up. So now that gives us an indication of what's going on with this model. I don't like the text here. It's a little bit too flush over. But you can see we're starting to build that dashboard. And I would also like to talk about what's going on here. And let's make these all at the same level. So I'm going to just control and click each one of these. And then I'm going to go over and go to general and go to properties and just make sure they're all at the same position vertically. So they're all going to be at 230. And so now they are set at 230. And we can just turn these off. And lastly, I want to call this out. So I do want to get a shape, go to insert shape. And I want to find a rectangle. and I want this to like just cover this area, but I'm going to push this all the way to the back, and I'm going to hollow that out. So style, I want this to be 100% transparency. I want a border. That border is kind of okay with me, and I need to push this back with format, and I need to send that all the way back, and I need to send this one all the way back. So this one might be somewhat of an issue, so I'm going to move this down a little bit and then see how it works. Move it up. So we're going to have to play around with this a bit because it is interfering. Let's see if we can get it without it shrinking. And let's make this come up a bit, so more into the, and this also more into our I want this, and then I'm going to press Control and copy all of these. Control. Sometimes it catches everything, sometimes it doesn't. Did it get the back? Yes. And then we want to pull, I still want to pull this down a little bit like that. But we still have, we need to bring all of these to the front. So 1, 2, 3. I'm going to go over to formatting and bring all those to the front. And let me make sure I turn these off. And I want to bring this forward. So I might have to play around with these quite a bit to get it the way I want. So I think because I don't want to keep playing around with it, I'm just going to go and make it bigger. So go here, canvas size. I'm still going to make the height one more time. I'm going to make it 14, and then I'm going to copy all of this with Control and pulling that over. I want to make sure I get the model, make sure all of those are selected. Then I'm going to bring it down, and then I'm going to bring this down, and then just make this a bit smaller, also a bit smaller, and there we go. So I also like to give things labels. So I'm going to take this text, copy, and just make sure they understand everything that's going on here. So I don't need this. So this is correlation of all the metrics that are numerical. We can understand which metrics are correlated, price, and how they are influenced. Formats, I want to bring that forward. And then still need to move this up. So that's my kind of dashboard. It's not we can continually play around with it, but this is what I have at the moment. And we can use this dashboard if we wanted to view it. For example, you can view to fit the width, and then you would be able to see the whole thing like this. So I would definitely continue to add indicators here that would give our reader the ability to understand what each one of these are, make all the labels super friendly. I'll do that, and then I'll definitely put this where you can download it. And then we will have this dashboard for our usage. Okay, here we are. We're going to do our linear regression from scratch. And I am going to take you through the code instead of typing it out so you get a little bit more information here. So we're importing our packages, pandas SPD, sklearn.linear model. This is where we get our linear regression. From sklearn.model selection, we're going to do a train test split. And this allows us to split that data up into a training and test set. Then we're going to get our standard scaler, which scales our data from a different values to putting it all on the scale. And then from sklearn.metrics, we're importing R squared and mean squared error. And remember that all the stuff that we built in Pycaret is based on that scikit-learn library. We bring in our data with that pandas variable, we read the CSV, and we get our data set here that we're pretty familiar with now. So in our Pycaret, there was some imputation going on, but you can see there's no non-null values, so I'm not really sure why there were missing values imputed there. So I didn't bring in any type of imputation from the libraries here. And okay, so the first thing we're going to do, and I should definitely label this, so we're going to create our dummy variables. And all that means is we are one hot encoding, and what that means is we're turning things into zeros and ones. And what I did here was I ran this, and we get our dummies variables, and the ones that I focused on were all the ones that had object here. So you can see the 3 or 4 here. We dropped the car name. We're going to drop that car name in a bit. So that is going to be something we do. And we probably actually need to drop the car name prior to actually running the dummy variables. So let's do that. So we are going to do df.drop. And we're going to drop our car name. And then we're going to do that on axis equals 1. Equals 1. And then I'm going to put one thing I haven't shown you guys. Like sometimes we have this parameter called in place. In place will save it as in the memory instead of adding the df in the front. So that means we don't need it here. So I'm going to run, and then let's take a peek at our data set while we're at it. So df.head, and let me run all this again so you can see it. Now, what you see with these dummy variables, they have been one hot encoded. So you can see we kind of get the sparse matrix where we get 0, 1, 0, 1 as something that is indicating what are these particular categories. Okay, so now we're going to create our x and y variable, which is our dependent and independent variable. So we know that our target's going to be that selling price, and we're just going to remove the selling price from this data set here, because this is what we're trying to predict. Then, so we already one hot encoded, so I'm going to get rid of this. So let me just rerun that because we've already done this. And now we have our code. So let's train, test, and split. So this function, train, test, split, we pass it our independent variable. We tell it the train size, how much data we want it to learn on. You can do 80, 20, 70, 30, but it's pretty standard to do 730. Then we have our random state of 1, 2, 3, so we can repeat those results. And if I run this, we get 4 variables. We get the training x, the test size X, which is the 70%, the 30%. Then we get the Y also, the 70% and the 30%. And then we are looking at the X data here. And you can see how this index is mixed up because it's being randomly selected for that training data. Then what we're going to do, we're going to scale our data. So first I ran this without the scaling to see what the results would be. So I put in standard scaler and then I initialize our model here. And then I can, once I have that model, we fit the data to that X train and Y training, which is a training session. And then we get predictions from that model. And I can show you what that looks like, Y pred. So those would be our predictions there. And we can compare those predictions to actuals with Y test. And then we get the 68 for our R-squared score. Okay, let's see if we get any improvements by bringing in our scaling of our data. So I am going to run this. So we are using standard scaler, and then we're using fit transform over our X and our X train and our X test. And this needs to be done separately because it's using the mean and the standard deviation to scale that data. So it's going to be different depending on what values are in your X test and your X train. So let me shift and enter that, and then we can see our values there. Then what I can do is I can take this variable for our X train S and then run this and shift and enter. And now we've trained it on that particular variable. So we'll see if our model does any better. And then we can X test on the S values and see what we get. And now we run this R squared and we can see if we got any improvements. And then we actually didn't do better. So that non-scaling of the data gave us a slightly better R squared score. Now, sometime you might get the difference, but it looks like we're firmly in R squared. But as you've seen before, we did cross-validation. Let me just quickly show you how to do that. So we need to bring this in. And this is cross-val score would be in the same as train test split. So we're going to do cross-val score. And now that we have that, we can bring that in. So let's add our cross-val score. So cross-val score. And then what I'm going to do, I'm going to add my model. I'm going to use X train and then Y train. And then what I'm going to ask for is CV equals 10 and for our folds. And then I'm going to do for our scoring, we're going to use that R squared, so R2. And then if we run this, you can see here are our squared scores. Not too bad. This is how it's doing. And if I took the mean, there is where we are. Because we have a different R squared, this means that it's learning our data really well. But then when we try to test it on unknown data, it's not doing so well. So I'm going to get rid of our model fit, and I'm just going to train it on the regular non-scale data and see if we do a little bit better. So it looks like, well, let's do this X test, and didn't do much better. So the problem is our data is not learning the training data very well, but not doing very well with prediction. but it's doing a little bit better when we do our cross-val score. So let's go up and quickly change. So we also had a extra tree regressor. So sklearn dot, I think it's ensemble, import extra tree regressor. And then we're going to run that, and let's add that model. So when we go down to model, we are here, and let's just comment that out, and let's do model equals extra tree regressor, and we run this. You see it's been initialized. We can do ypreds, looking already better. Run IR squared, it definitely improves. And if we run our cross-val score and we take the mean, we are doing a lot better. So it's definitely better at learning and testing our data. So this is a great time to talk about overfitting and underfitting our models. So you know that we are using machine learning models. So the goal is for our model to be robust enough to be able to give accurate predictions, even if it's faced with new data. We don't want the model to just be able to perform well on the data we gave it. We want it to perform well on the data that is upcoming or new data for it to predict on. So there are some terms such as overfitting and underfitting in machine learning. So overfitting occurs when a model learns the training data too well. So that means it captures all of the noise and the random variations, but that is not always good, because that is including that in the overall pattern that it's using to predict. This means like once we use it, the results are going to be really poor in the testing set. So to give you an analogy, it's like memorizing the answers instead of understanding the concept. That's overfitting. So just remember that it does well with the training data and poorly with the testing data. Underfitting happens when the model is too simple to capture any real pattern. So it fails to perform well on both training and testing. So it's just a bad model overall. There may be some things that we need to do to make it more robust. You can think of oversimplifying a complex concept, like using a measuring ruler to measure everything, even in a 3D space. So what we're looking for is, overall, we're looking for balance. We want to avoid overfitting, which is learning too much of the training data. We want to avoid underfitting, which is learning too little and oversimplifying. And we want a balanced model that performs well on the training and the testing set, so we can have something that we can use. So we will look into some of this and see this occur in some of our models. Okay, so we should be pretty familiar with some of the workflow when it takes to building a model. So we're going to dive a little bit more into some detail now. So I won't live code as much. So we're importing our libraries: matplotlib, pandas, seaborn, Pycaret, classification, because now we're dealing with a classification model where we're trying to predict a specific class. And we'll talk about that data in a minute. We are going to use pandas profiling report for our EDA. We're going to import warnings and ignore them. For our data, we're looking at an HR data set. We're reading in that data set with pandas. And then we look at the data.head. And you can see here are the columns. So they're all related to employees. And then we have what we're trying to predict is whether they quit the company. Then we do a little bit of EDA where we look at the columns, and we are missing some values. So we have about 15,000 rows, And then it looks like we're missing some values here. So let's use that pandas profile report to do a little bit of EDA. So you can see it ran. I've already run it. And then what we get is this overview report. And we can see we're getting the same 15,000 report, 14 missing cells. We got 6 numeric, 5 categorical. So this is going to give us quite a bit of information. Now the reason I like doing the pandas profile and report with this particular data set is because I can get an idea of what is needed, and I like the alerts because I think this thing is usually overkill, and it may confuse you, but the alerts are fantastic. And now that you have a sense of correlation that we looked at in the previous linear regression model, let's look at this with classification. So here is some great information. So the data set has 9.8% duplicate rows, so we would just drop those, that's 10%. And then we have satisfaction level is highly correlated with the person who quit the company, which makes perfect sense. The number of projects is highly correlated with quit the company. I don't know which direction that's going in, negative or positive. If the person's in management is highly correlated with quit the company. And then quit the company is also highly correlated with the satisfaction level in 2 other fields. Promoted in the last year is also highly imbalanced because most people are not going to get promoted. And management has the most amount, has 76.4% zeros. So that's something that we need to look at. So we can isolate all those variables here. So I can go to quit the company, and we can see we only have this amount of people who actually quit, about 3,500 out of that 15,000 employees. So if we broke that up, 1,100 people are still at the company. We can look at the last evaluation and all these things in these visuals, satisfaction level. And this is a modified hex plot. Let me zoom out a bit. Hex plots can be a little bit difficult to understand, but if you have some good variables, it's pretty easy. So we're controlling the monthly hours and management, satisfaction level. So we can see a little bit here what's going on. Number of projects. Another part that we may want to look at, any missing values. So we can take a look at that, what the missing values are. This also gives you the head of the data. But I like the correlations, and I like some of the heat maps and things like that, which are really good to see. We can definitely get a lot of good information. I think it's just best to know what you're looking for. And here's that correlation matrix that we like to use. And we can see what's correlated with what. And if we just isolate that quit the company, we can see what's really highly correlated with that, which has indicated management. So we might see that pop up in our feature importance or our coefficients. So let me close this up. Let's do a setup. So in the setup, we already know how we set up our Pycaret experiment. We're pulling in that data frame. The target is quit the company. We're normalizing that data, so essentially scaling it and doing the session ID, which is our random state of 1, 2, 3. If we get the repeated information here, and you can see after things have transformed, done some of that one transform things, those columns, let me just go up here. So remember that we have 11 columns here. But when we go down, you can see if any transformations happen, the shape of that data has changed to 22, so doubled the columns. And here's a test set and the training set now that we have seen how those things are broken up. And then our target is binary, so whether they quit or not. Okay, so then we do our compare models to see all the models that are there. There's a lot of models here. So we can see some of those ensemble models, gradient boosting, decision tree classifier, a gradient boosting classifier, and random forest. And then if we look at purely logistic regression, it's down here. But you can see these are all very much doing a good job at predicting. And we need to talk about these particular metrics because they're different from your linear regression one. So let's talk about these metrics. Obviously, accuracy is the ability to be correct when we are looking at the model. This AUC is how well the model is actually working. So if your AUC is a 0.5, that means the model is no better than flipping a coin. As you can see, it goes from 0 to 1. So it is really good at understanding the data. When we get to recall, recall is about capturing all of the positive cases. So it's trying to capture all out of all of the employees who truly left and how many did we correctly predict. When you start looking at precision, it's about accuracy. So it's about if we're trying to look at the accuracy of our positive prediction. Precision being true positives over true positive plus false negatives. And then recall being true positives divided by true positive plus the false negative. So those are going to be the metrics we look at. So you can see we chose that LGBM classifier. Here are all of the different parameters there. So we can definitely tune this. I'm just going to start off with logistic regression so we can talk about this a little bit more. So you can see I chose the LR model. And then if I choose that LR model, we can see what happens is it's still amazingly good. Look at the precision. So we can evaluate our model here. We can definitely look at the pipeline and all of the different steps that have been done. One hot encoding and imputation is something that was done here. So we can also look at all the hyperparameters that were used in this model. So if there are still a lot to do in logistic regression that we can use. Confusion matrix, so you can see out of the predictions, this is the true class and this is the predicted class. So we can see how many we correctly predicted here. We incorrectly predicted 67. That's why that percentage is so high when we're looking at that confusion matrix. We can look at feature importance, and as our model kind of we saw in our EDA, we have management is dominating variable importance. We can tune our model, as you see here, so we can use tune model. We pass it our model, and then we still have these pretty amazing results. And then if we do predict using our tune model, you can see our scores are here pretty fantastic. And let me zoom out a little bit. And then what we get is quite good. What we get is we get a prediction label, so whether we predict it correctly or not, and a probability score, how well or confident the model is at predicting whether that's a person leaving or not. And here's the plot model where we're looking at the tune model, and I looked at the confusion matrix. We can represent any of these particular visuals if we want, but I just chose the confusion matrix. And let's go ahead and save our model. So let's use save model. And I'm going to save this as trial class for mine. And then I pass in my model. We're going to use that tune model. And we should be able to run this. And then we can see everything that is being done to all our columns. And we should be ready to go with our tune model. And we can even see all of the particular things were tuned here. Okay, let's build this from scratch. We're going to use all those sklearn modules. So let's go through this. It's going to be a little bit more than what we have done in the previous lessons. So we're going to import these packages, pandas, sklearn logistic regression. That's the one we are using as our test. Of course, if you want to do extra tree, which we used before, that's going to be your ensemble. So you're going to get that from the ensemble method there. Metrics, we're going to look at accuracy score, confusion matrix, and then we're going to display the confusion matrix. From sklearn model selection, we do our train test split and our validation score. sklearn pre-processing, we're going to use label encoder, and I'll tell you why when we go over the data. And then we're going to use standard scaler. We might get benefit from scaling our data or not, but we definitely will need to one-hot encode and use a label encoder. Seaborn for visualization, matplotlib, and then I'm going to import warnings because I'm going to ignore the warnings that pop up. We bring in our CSV as it is, satisfaction level, and the last evaluation, and all of this stuff that we've gone over before, and then our management score there. So for label, you can see we do have some categoricals here. We have departments, which just indicates which department you're in. And then you have your salary here. So as you see here, we have the satisfaction level. And everything here is mostly floats and integers. And then we have those two objects. So if I look for any missing values, because we can see some null values here, because we like have 1504, and then it looks like there are some null values, so I ran an isNull function to give me the true and false. Then I ran the sum, and then I plotted it, and I got a bar horizontal. And we can see that's work accidents, total time at the company, and number of projects. And these are not a lot. You can see it maxes out at 5. So I'm just going to drop those as I did here where I dropped those. And then you can see everything goes to 14,999 and with non-null values. Then I wanted to see how many of our data set actually quit the company. So 1 is an indication of quit the company. So there's about 3,500 who in the data set that have quit. And then I wanted to see in which of our departments do we have the most salary discrepancies, whether it's high, low, and medium, and that's a categorical. So you can see here, if we look over, when we go over to management, they have the highest salary, of course, and the percentage is, over 35%. It's pretty equally split between medium. Low salaries, we're looking at some departments like the production here and support. So I wanted to see how that actually affects everything. I did a plot also to see if the salary and satisfaction level were more on the lower end. So satisfaction level, let me zoom out slightly. Satisfaction level is here. And you can see that we have a longer tip here for low satisfaction. The median is this little dot. So you see the median for satisfaction level is lower. And then they have a fatter tail here, which means there's more there than on the other levels. So this is my kind of EDA portion. I took the columns here and then I put everything in one-hot encoding except the salary level. So you can see I use get dummies to make that 0 and 1. And then we have all these zeros and ones for our new columns for departments. Now I want to label encode the salary here. Let me zoom in a bit. Because there's levels, right? It's low, medium, and high. So we have to use a different type of encoding. And I use label encoder. So you can see I instantiated label encoder, and then I did fit and transform. And that gave me 1, 2, and 3 for this. Then looks like we have an extra one here. Then I define X and Y, right, for our dependent and independent variable. So quit the company as I target, so that's our Y. I did the train test split here and got the 70%. I scaled the data here, but I didn't use it. It's just yet. Because we saw in our previous Pycaret that it was doing really well without the scaling. Then I instantiated the model for logistic regression, fit the data, so had it learn our X train and Y train. And remember, we get those 4 variables from this function, which is the X train, X test, Y train, and Y test. Then I ran a prediction across our held out data, which is the X test. And then I got an accuracy score between our actual values here, which is Y test, and then our predicted values. And see, we had an accuracy score of 99% or 99.6% exactly. I ran the cross-val score, and we also see these pretty good results. So no point in pulling scaling data in there with this type of performance. I got the confusion matrix here, and I passed in. First, I ran the confusion matrix, and we passed it our Y test and Y pred. And you can see we do have some false positives here where we predicted not quit, but they actually quit. But we still are super accurate here if there's only 33 that we mislabeled there. And we didn't mislabel any ones that were in the not quit zone. So, for prediction. And remember, this confusion matrix is flipped. We use confusion matrix display. We pass in. You can see I saved the confusion matrix here. Then I changed the labels here, and then I plotted it. So you have to pass in the confusion matrix, your labels, and then you just use the dot plot to get all of that. Lastly, because we're using logistic regression, we know we have a coefficients there. And if you take a look, the data frame, I zipped the X columns, and I actually had to flatten the coefficients in the list because it was double bracketed, which would indicate that it was not a list. So I used model underscore coef, and then I flattened that out, zipped that together, passed in a data frame, gave the column feature, sorted the values by our coefficient, and did that in a descending fashion. And you can see as feature importance, the most important thing in our feature importance, which is using a tree-based system, which is slightly different from your coefficients, is management also. And then we have our salary, total time. So, and these departments are also departments that were indicating whether people were happy or not. The monthly hours. So these are the things that are negatively affecting that prediction ability. Now, the one thing we need to do that we haven't done is if we use prediction here, we can actually predict the probability also, but we just have to use a different function. So it's like model pred.probability, predict proba. And as we saw in that Pycaret, it does both. So we would need to add this back to our data set. And let's see if we can run this. We need to pass in our X test. And then you can see we get those probabilities of whether they're going to churn or not. So that is our information. And let's bring this into our notebook. So let's talk about this model. We have done a model from scratch, and we saw that management was something that outweighed everything. Here is the coefficients in this zipped model features in name and the model coefficients. I flattened, and then we have this column features with the coefficients. And if we look down here, we can see management is really outweighed and imbalanced. So without any further context of what management is, we can see if we run a visual here for the management, we can see this is super skewed while the majority of our values are 0. So what should we do in that? We notice this is improperly influencing our model. So what we can do is we can go back up to the top of where we started our model. And then we can just go and add another parameter. We want to add ignore features. And we add management. And then all we're going to do is run this again. And then we can just hit run all below. And let that resave over our model so we can get a updated class. So this will not be in here. So now we can let that go. So let's take a look at what happened to our accuracy. You can see that it dropped quite a bit for logistic regression. If we go back up to our model comparison, you can see we are, where's our model comparison? We are definitely not in the top for logistic regression. And it seems that the tree-based models are better at getting us what we want. So we definitely could add a tree-based model here if we want. So we could add, random forest classifier, XGBoost, and then we could use feature selection or feature importance to give us what we are looking for. So when we add this to our model, we know we need to drop that feature because it was far outweighed. So let's go down and look at the coefficients. We can look, let's type in coef here. So here are the coefficients. So for our linear regression, if we take a look at this and maybe let's sort the values. Let's make a little room here. So we're going to say ascending equals false. And we have a little error, coefficient, sorry. The name of the data set is actually coef. So coefficient. And now let's run this. So now we get a total different feature for our prediction. So time at the company is a predictor. So the longer they are staying, the more they are predictable to go. Salary low is also something that we can see as a predictor. So now this makes much more sense. So I think we should feel very comfortable with using another model and possibly dropping our management. So if we wanted to use another model, we know all we need to do is go up to where our model is and add a different model here. And it will tune everything. So I'm going to pass in the random forest classifier here, RF. Then what I'm going to do is instead of having for coefficient the actual model coef, I'm going to add the model, and then we can do feature. Oh, we can't use it. Well, we can say feature importance, even though it's not importance underscore. And let's run that from our section above where we have brought in our model here. So we're using the random forest classifier. So we're going to run everything, run all below. And we should see different results. So while this is running, I'll show you how to drop that from our X data here. So this is our X data. So we quit the company from our features that we're training. So all we need to do here is we add a list, and then we're going to drop also management. And we can run this whole thing, and then we will get similar results as we have before. So let's go back over to our Pycaret notebook. So now that we've run that, you can see we still get a great level of accuracy, even though we're not bringing in that management. We definitely have a few false positives here. As you can see, we were bringing in 0 before. And then we saved our model again with that trial class. So now we have updated our model, and this is feature importances, I believe. Let's see. Yeah, in feature importances, so I can run that. And now you can see what we get when we actually run that tree-based model. Satisfaction level and time of the company is what is our main predictors. Also, we see the number of projects. So this definitely gives us a different view of what would be considered important for that decision making. So here we are in Power BI, Power Query Editor. We have brought in our HR data set, as you see here. And then, as we've done in the previous videos, we have done a prediction here with our 2 columns with our prediction score, which is going to be your probability score, and then your prediction label, which is whether it's a churn or not, and placed in binary 1 and 0s. Now, if we can go back and look at the code here by just clicking run Python script, and you can see from Pycaret.classification, we imported everything. We loaded our model, and using the load model function, I used the whole path to bring in my model. You may have to also. And then we just ran the predict model function, passed in our save model, and ran it over our data set. So let me cancel that out. And then it gave us a table, which is 2 predictions, and that's all we have. And then for the next table, it's almost the same code, but what I wanted to do is get that feature importance. And it's pretty much the same code. We get a prediction data set back also. And then all I did was add in the data frame, which is a zip module features in. And then the model feature importance flatten as we saw in our code on our Jupyter Notebook. So let's go in and build our dashboard. I'm going to close and apply this. Alrighty, so I'm going to make this a pretty simple dashboard. I definitely want to be able to bring in my coefficients. That's really important for me. So I kind of want that to be the centerpiece, because I want this to be known that, hey, these are the reasons we need to worry about in terms of why someone is leaving. So I'm going to kind of make this a centerpiece. And then here in this section, I want to have a text explaining why we are seeing churn. So I just wrote some stuff up here, so I'm going to copy and paste this, and I am just going to provide this to management. I just want to bold these so that management can really see them. So we already have 2. I'm going to take off this title because I don't like the way it looks. So now we have the first area of our dashboard. So I'm going to just even this out. Also going to get rid of the x-axis here, and also deal with go into the x-axis here, and I'm going to get rid of the title also. I'm going to add the labels here. So I go to data labels on. And then I am going to simplify this a little bit more. What I think would be better is to multiply these by 100. So what we can do is we can go to your feature importance here, go to new measure, and then we go to measures, and then we go to our coefficient. We got to bring it the sum of coefficient, and we get that from my coefficient value there from my, and then we just multiply it by 100 just so we can have something that is not all zeros here. Feature importance import, let me spell this right. So now what I'm going to do is I'm going to go and click into the visual, go to build visual, and then I'm just going to replace this by moving it over. So let's filter this out so we only bring back the things that are in feature importance there. So we want to go in and go to sum of coefficients, and I want to say that is greater than 0.01, and I'm going to apply that, and then we get this nice little feature importance there. Now that we have that, I would like to get some other parts of our model that are important, so that this is going to be the recommendations, and here I'm going to put in some metrics such as satisfaction level, and I'm going to turn that into a small box here, so I don't want them that big. So I'm going to go over, I'm going to go to call out value, and then I'm going to turn that into Sugoi bold, and then I'm going to bring this all the way down to, let's say, even smaller. Let's go with 16. And then let's get our label correct, which is going to be, I'm going to bring that down to 8. And now I kind of have what I want this to look like, because what I want is a bunch of boxes like this. So I'm going to bring this over like this, bring this over like this, and we get all those on the same level in 1 second. Maybe do one like this, and one like this, and I'm going to highlight all of them, just bring them up a bit, and we can level them off pretty easily. Now what I want to do is add a level to each one of them. So I'm going to highlight all those. These look pretty level. These are not level, as you can see here. So these two are. And we level that off. Then I'm just going to go to insert. And I am going to get a shape. I'm going to pull in some lines here. And now I want to be able to bring in, we have sum of satisfaction, but we want average. We want we want to make sure we see all of these total time at the company. So I'm going to, total time at the company. And I'm going to take the average there. And I'm going to also get the number of projects. So we got average number of projects. Then we also want to get the last evaluation. So I'm going to get last evaluation here and put that average. Then I want to now keep with the kind of theme here. As you can see, these are more on the particular employee. Now I kind of want to make sure I add other values down here, last evaluation. And let's add the monthly hours. And then let's add our work accidents. And we put average. Oh, sorry, wrong one. Let's pull that out. Pull that out again. Here, let's do average. Work accidents. Turn that into an average. So now we have this particular table here. And so I'm assuming they're going to be reading from left to right, so we can label this our what is causing our employees to leave. We can call this our employee metrics. We call this our recommendations. And then I want to have one more visual here. And then we can add a few. So here what I want to do is get that salary. So I'm going to get salary. And then we have these three levels here. And then I'm going to get the amount of people who already quit the company. And so they have a very good visual of who is actually quitting. Salary like this. And then legend, we have the amount of people who quit the company. So we can kind of see the percentage of users that actually quit the company if we have it like this. You can also turn this into a chart like this. So you can see the percentage of churn, which I think is quite nice. We probably want to change these values here, but let's get rid of the title here. And let's add labels. And then I want those labels, values. Let's put 0 because I don't care about the values. So you can see, we can definitely see that people with high salaries are not leaving the company. So at this point in the video, what I'm going to do is kind of speed up some of my actions because a lot of it is just fiddling with the way the dashboard looks. So you can see I've added a background to that text box, and I am going to be realigning things at the moment. But what we want to do is be able to get a heading over each one of these particular shapes or graphs, and I'm just going to do that with a text box and add that in over each one. Now also a big part of kind of making your dashboard stick out is definitely adding headings and also adding icons. So what I'm going to show you now is how to go over and find icons, and these icons are in quite a lot of places, but I'm just finishing up the titling here. So we're going to go to a site called Flat Icons, and Flat Icons provides us with a lot of free icons. You can do a search, so I'm just searching for employee, and you can see how you get these icons here, and we can download them and add them to our dashboard. So this will allow your dashboard to pop a little bit, so you should get as many as you need because they're free. So we can easily bring these in by using Insert Image from the top bar. And you just find out where you downloaded and just bring those in, and you can see they're quite movable, so you can move them all around and add them to different portions of your dashboard, so it gives it a little bit of better look. What I'm doing now is just adding the number of users to our dashboard. Now I don't want to add just the number of users, so what I want to do is I want to filter this. So I am going to bring 2 of these in, and I create a basic filter where I use that churn or quit the company dimension and just filter by 0s and 1s to get the employee count and the total churn. Now I'm just adding some headings and just going to be cleaning up the dashboard, but we're pretty much already there. So I'm just going to add some filters at the top. I'm going to switch these to drop downs because I didn't realize how long the list was. So I'm going to add 2 drop downs at the top, which are going to be giving the user the ability to select through the department and the salary type. So what I'm going to be doing is just bringing in all those icons that I want and placing them over each one of our headings to make it look a little better. You know, you got to play around with the sizes so it pops a little bit better. Once I get all those icons in, I kind of want to play around with some of the headings. So I'm going to bring a heading in just by bringing in a shape and then writing in a title with a white background, and I'm just going to pull this through the shape here and just give it a more in-depth name or a more detailed name so it looks like it's a little bit better. Then I want to take that chart that I have, and what we're going to do, we're going to go over to conditional formatting, and we're going to change that chart to where it is blue and gray. Then we want to make sure the chart on the bottom also has blue and gray. Then we add a couple dividers and change those into gray. I keep playing around with the colors with the conditional format to make it look a little bit better. And I've just experimented a little bit with the different colors, and we are like 90% there. So this essentially is the final dashboard here where we have our different layouts. And what we want to be able to do is just make this a little bit more transparent so it is not so ugly when we are looking at it. We have all our titles, we have our icons, and we also have our filters that allow us to filter the whole dashboard based on that department and also those salaries. Now, if we filter on salary, we know it's going to filter the bottom chart completely. So it's going to be up to you how you want that to be filtered. Maybe we can use edit interactions to remove that. But I hope this dashboard inspires you to make something even better.